is Dominic Diaz, and today I'm going to be presenting our Spring 2023 Senior Design Project, the P2P Drive. First things first, I'm just going to give you guys an overview of how I'm going to do this introduction. First, I'm going to jump into the problems which we address with the P2P Drive. We're going to then discuss the current systems in place. Then we're going to go over the new system which we're introducing. After that, we're going to jump into the components required to create this system, its current use cases and functionalities, a sequence diagram which will display the kind of back-end side of things and how it functions, and then we're going to go over a brief system overview. Is to showcase a viable solution to data storage concerns such as high cost, the vulnerability of a centralized network, security, and also scalability limitations. To give a small idea of current systems in place, data is usually stored on a centralized server which is controlled by one or more entities. Usually storage costs can be high because it's expensive hardware as well as maintenance. Redundancy and data loss concerns exist if the server fails or experiences any downtime. Security can be compromised as the data is stored in a centralized location, and scalability can be limited. Now that we've gone over a small bit of how current systems work, now let's talk about the new system that we've created. This system utilizes IPFS network in order to store and distribute data across a network of nodes, ensuring redundancy and accessibility even in the event of our node failures. This is the complete opposite, of course, than a centralized network. So in the case of our servers going offline, one or multiple, we still can ensure the backup of our data. We also can use the decentralized nature and server-side pinning to enhance the security, which will make it so that only authorized nodes can access certain data. And to take it even a step further, authorized nodes and users, which because we utilize Firebase as well, in order to encrypt the files which are already encrypted by our nodes, essentially. So it is very secure as well as very scalable. So our new system tackles pretty much all of the problems which we had addressed in the previous slide. So now what we'll do is talk about the components of this. In order to put all of this together, we utilize IPFS. Everything in terms of the file system is built upon IPFS. And in order to have a user base, we of course use Firebase. The front end was built in Angular and TypeScript, and the back end was built completely in Golang. The reason why we use Firebase is not to organize anything. All of the organization is handled completely by IPFS. There's a, framework or library built upon IPFS called the mutable file system, which when files are changed and the hashes change and are updated, it allows for us to keep track of them as they're changing in the network. So with this, in combination with Firebase, it allows for us to create user directories, track files, move them, and it abstracts all the complication that comes with IPFS for the user. Now we also have GoFiber down here, and this is for our API. So our API was built in Golang, and the framework which we use is GoFiber. Postman, this was something that we used throughout building this a lot because of just testing requests. We actually do virus checks on the files. That was just like a small addition that we had added. And then, of course, just we added Git here because as we were constantly moving through this, Git was very prominent. So now into our use case diagram and functionality. So this is kind of a small brief overview. We're going to go into a more detailed version of this, but just to show you guys, we have a login, we've got a register, and then of course, if you forget your password, you can send a reset email. This is for an unregistered user. So this whole top half would be unregistered users. Now, once you're registered, you will have the ability to view files, and through viewing files, you will be able to upload your files, remove your files, download your files, and also view your peers, which is all of the people you're connected to in IPFS and the local nodes which are helping you inside of the network, essentially. You'll also have your view settings and your account information, and also logging out. Now to hop into a little bit more of a detailed version of this. So when you create your account inside of our front end, what happens is the server checks IPFS to see if that user has been created before, because if the user has been created before, IPFS would have a folder for that user. So we check IPFS for the folder. Once we check IPFS, if it's not there, then we check the database for the user ID. If that's not there, then we enter this conditional, which essentially will tell us if the user does not exist, this is what we do, and if the user does exist, then this is what we return. So in the case that it does not exist, then what we do is we add the user to the database. Once the user is added to the database, we'll have a user ID. So we take that user ID, we send that back over to our server. The server will take that, create a folder with it inside of the IPFS network. Then after it's successfully created, it will return a success message which will go back to the user. That is what happens when you register. So what's happening here is we're leveraging the IPFS network for its folders and capabilities of that nature, and we're also leveraging Firebase for the ability to create users. Now, once you log in, you will, of course, when successful, you will get returned, and this kind of happens in the front end. This is what gets returned through the front end. Once you log in, you automatically get sent over a JSON object which will represent your own directory. So in this directory, you'll see all of your folders represented in JSON, but as a user on the front end, you'll just see them on your dashboard. So now if you want to add a file, what's going to happen is you will be logged in. Now you're going to upload your file. We're going to check IPFS to see if that file exists within the directory that it's being uploaded, and then we enter this conditional, which is if the file or folder does not exist. So if it doesn't exist, we send that file as a form file request over to IPFS. It's going to return a object which represents the file over back to our server. And then we're going to store some of that information to connect it to a user into Firebase. This is very important, and this allows us to later on connect encryption and things of that nature. So that's why we store some of the data, such as the hash, for Firebase. Then, of course, we return successful, and we return file uploaded with a JSON object representing the directories. Now, this is just a representation of how things work, and it is quite a mouthful to say, I will say that, but on the back end of things, this is how it works in a nutshell. And so now, just to give you guys a small overview, here are the different objectives and the different goals which we have essentially tackled, and some of them which are present in a centralized network. So we have a decentralized system which will allow for us to reduce the reliance on a single server or data center. We have cost efficiency, we have data deduplication, we have lower bandwidth costs, scalability savings, and we also have reduced latency. And so just to kind of hit every point really quickly for you guys here, the cost efficiency is due to the fact that we don't have dedicated servers or some large data center. We're actually leveraging the IPFS network as a whole. And so that allows for us to have a very resilient network, although we don't even own our own network, so to speak. Also, with data deduplication, it allows for us to store the files on the network. And if we notice that, let's say a user has two files which are identical, we can store that content in one address and not have to waste memory on our side of the network. When it comes to lower bandwidth costs, that's actually because of the fact that we are connecting always to the nearest nodes to us. So IPFS will automatically always connect to the closest nodes in order to reduce latency. And by doing that, it's also reducing bandwidth costs. So what companies will normally do is they'll have data centers distributed across the United States, which can be quite expensive. And so what we would do rather is get small servers which connect to our network, and those small servers can serve files in those places using local nodes. Also, scalability savings. Scaling our network would be as simple as getting another node, getting another server, and adding it to the current IPFS network that we already have. So, in terms of scalability, it really is great. And then, as we were covering in low bandwidth, because of the fact that we're always connecting to local nodes, this means reduced latency. Connecting to a node inside of Canada versus connecting to a node that's local here in Miami, that's pretty much the difference between 30 millisecond latency and 300 latency. So IPFS really takes care of this. And so this is pretty much just an overview. I hope you guys enjoyed, and definitely go check out the demo video. Thanks, guys.